Dear students, Vetri welcomes you all. I am Dr. Gunasekaran, going to discuss NEET original question paper under the topic Unit 12 Coordination Compounds between the years 20 to 25. The first question in the coordination compound is question number 1. The IUPAC name of the complex within square bracket AgH2O twice and within square bracket AgCN twice is NEET 22. This question was asked in the year NEET 22. Options are number 1, dicynido silver 1, diaqua argentate 1. Number 2, diaqua silver 1, dicynido argentate 1. Number 3, dicynido silver 2, diaqua argentate 2. Number 4, diaqua silver 2, dicynido argentate 2. So this is the questions. So before naming a complex, you must know the types of complex available in the literature, in the book. So normally, there are 4 types of complex. There are 4 types of complex. One is simple neutral complex. Simple neutral complex. 2, anionic complex. Anionic complex means potassium is cation and FeCN6 anion. This is called potassium ferricyanide. And the IUPAC name is different. This is potassium hexacyanoferrate 3. Now cationic complex, the complex is cation and the anion is the symbol. Example, tetramine copper 2 sulfate. And the 4th type, cationic and anionic complex. In one complex, the cation will be, in the complex, the metal will be positive. The second is, the positive means that a complex ion is positive ion. And the second part, the including metal complex is the negative ion. This is called cationic and anionic complex. Kindly follow. So now we should be very carefully name this compound. What is the name of the compound? Kindly follow now. So here, this is the cation. This is the anion. Both cases silver. So we will say that means argent. So here, the most important information here, the most probable answer may be 2. Because diaqua silver 1, because water is neutral, so Ag plus, that is 1, diaqua silver 1. In this case, dicyno argentate 1. Dicyno argentate 1. So automatically, one is positive 1, another is negative 1. The complex is neutral. The correct answer may be 2 is the correct answer. So, let me go for the answer The correct answer is 2 is the correct answer. So when you are doing the naming, you should be very, very careful. The next question. The energy, kindly follow. The energy, or the order of energy absorbed, which is responsible for the color of the complexes. Question was asked in NEET 22. A. Nickel H2O twice, En2 2 plus. En means ethylene diamine. Ethylene diamine. So this is normally written in this form in chemistry. In coordination chemistry, ethylene diamine will be written in the short form En. So En twice. Kindly follow. So the interesting information is the order of energy absorbed, which is responsible for the color of the complexes. A. NiS2O twice, En2 2 plus. B. NiS2O4, En2 plus. And C. NiEN3 2 plus. So, which is the correct order? Kindly follow. In this case, we must know the relationship between the energy and lambda. Energy and lambda. So, for that, here, I want to see here, let's see here, if visible light falls on the complex, the electron absorbs a photon of energy to delta 0 value, that is crystal field energy values, and jumps from lower d orbital to higher d orbital. Say for example, 3D in octahedral complex, say dxy, dyz, and dzx. Here d squared y square d z square. So what will happen now? When electron jumps from lower level by energy, by absorption of energy, it will move to the higher energy. This is the important information you must know. If visible light falls on the complex, the electron absorbs a photon of energy, so that the difference is delta 0. The difference between the higher and lower energy orbitals, this value, it is delta 0 values, and jump from a lower d orbital to higher orbital. The lower the energy, higher will be lambda. Very, very important. So for that, we know the equation E equal to h nu or E equal to SE by lambda. Please follow. That means, in this case, E energy, lambda here inversely proportional. So higher the lambda, lower is the energy, or lower the lambda, higher the energy. In the case of VGR normally will be written, if you go for any Photoshop, what is that? V for violet, indigo, blue, green, yellow, orange, red. This is the increasing value of lambda value. So R, red is having higher lambda. The next orange lower, yellow lower, green lower. So lowest will be violet. Okay. So now what we have to do now? So in the questions, kindly follow. There are three options are given. A, NiH2O twice, En twice 2 plus. So in E1 ethylene diamine, kindly follow the electron to lone pair. That's why it is ethylene diamond is a didentate ligand. Didentate ligand. The next is single. And third is 3. Kindly follow. So the order should be, so C should be greater than A, then greater than B. Because in C, 3 En is there. In A, 2 En is there. In B, 1 En is there. So, very clearly, now you can go for the correct answer is, this is the correct answer. 1 is the correct answer. C greater than, A greater than B. Kindly follow. Next question. Given below are two statements. One is labeled as assertion A and the other is labeled as reason R. NEET 23. Third question. Kindly follow. So this is question asked in NEET 23. Assertion A, metallic sodium dissolves in liquid ammonia giving deep blue solution, which is paramagnetic. Then, reason the deep blue solution is due to the formation of amide. This is the reason R. Kindly follow. Now, so in this case, what the correct answer here is, the correct answer is A is true, but R is false. This is the correct answer. A is true, but R is false. A, what is A? That a metallic sodium dissolves in liquid ammonia give a deep blue solution because it is solvated by electron, ammonia molecule, it is blue color. Whereas the deep blue solution is due to the formation of amide, it is wrong. It is false. Kindly follow. So, this is the correct answer. Next one. Question number 4. Homoleptic complex from the following complex is NEET 23. Homolytic complex. What is meant by homolytic complex? It's a new term we are introducing here. We have not studied in the book. My dear students, we have not studied in the book. A. Diamine chlorido nitrito N platinum 2. Do pentaamine carbonato cobalt 3 chloride. 3. Triamine triaqua chromium 3 chloride. 4. Potassium trioxalato aluminate 3. There are 4 options. Homolytic complex from the following complexes. So, which is homoleptic complex? So, first you must know what is homoleptic complex. Let me explain now. What is homoleptic complex? A homoleptic complex is a type of coordination complex in which the bonding involves Homolytic cleavages of the ligand. So ligand will be homolytic, same, meaning that the ligand undergoes symmetrical bond breaking forming radical. So the ligands will be symmetrical. A classical example is cobalt carbon bond in vitamin B12, that is cobalamin derivative. Kindly follow. So a specific example here I want to give here. The formula is for potassium trioxalato aluminate 3 is K3Al C2O4 thrice. So complex C2O4 is the ligand. So these three ligands are identical. So this type of ligand we will call it as the correspondingly the name is homolytic complex. Homoleptic complex. So this is the example. So answer is 4 is the correct answer. Potassium trioxalato aluminate 3 is the correct answer. Number 5. Now, which complex, commonly follow, is most stable? Which complex is most stable? That is, kindly follow 1. CONH3 twice, NO3 thrice. B. COCl2En twice, NO3. CONH3 6, within bracket, twice, SO4 thrice. 4. CONH3 4, H2O Br NO3 twice. There are 4 complexes. All complexes are the first one neutral complex, the second one cationic complex, third one cationic complex, and fourth one also cationic complex. Kindly follow. So out of which is the most stable? So how to identify the most stable? So any ligand which is having the more dentate ligand, that is denoting lone pair is more number, that will be more stable. Kindly follow. So in that case, probably 2 is having ethylene diamine, 2 times it is, probably it will be more stable. So here I will want to give some explanation. Explanation is factors which influence the stability of the complex. Number 1, nature of metal. Higher the charge, higher will be stability. For example, sodium complex and aluminum complex, charge will be higher aluminum, so aluminum complex will be more stable. Number 2, smaller the cation, higher the stability. So cationic size is smaller, stability will be higher. Second information you must know. And third one, half filled and completely filled orbital in the metal complex ion will be more stable. So this information is most important regarding for nature of metal ion. So from the metal ion we can identify the stability. Number 2, factors which influence the stability of the complex ion. P23. Nature of ligand. A. Charge on the ligand. Negatively charged ligands will form more stable complex. Basicity. More basic ligand will form stable complex. Size. Smaller ligands will favor stable complex. And chelation effect. Polytented ligand will favor more stability of the complex. Kindly follow. So, automatically the correct answer is 2. Ethylene diamine, it is didentate, the didentate ligand 2 times, it is more stable. I hope I can stop here. I will continue the remaining question in the next chapter. See you again. Bye bye. Dr. Kudasekharan.